Good day, learners. Today we are going to discuss finding the arc length, one of the application of radian measure. But before anything else, do not forget to like, share, subscribe, and hit the notification bell so that you will be updated for my upcoming videos.
Uno, dos, tres, cuatro.
In this video lesson, we are going to discuss finding the arc length of a circle, one of the application of radian measure. The radian measure formula, theta is equal to intercepted arc over the radius, can be used to measure arc length along a circle. For a circle of radius r, a central angle theta intercepts an arc of length s, which is the intercepted arc, given by the s, or the intercepted arc, is equal to the radius times the central angle, or the theta. And this is now the formula in finding the length of the circular arc, where theta is measured in radians. Note that if r is equal to 1, then s is equal to theta, and the radian measure of theta equals the arc length. Example number 1. A circle has a radius of 3 inches. Find the length of the arc intercepted by a central angle of 240 degrees as shown at the left. As what you can see, this is now our angle measuring 240 degrees, which is equal to the theta, and this is now our arc with the radius of 3 inches. So what are we going to do is to use the formula S is equal to radius times the central angle theta, or the angle theta. First, convert 240 degrees to radian measure. So we have 240 degrees times pi radian over 180 degrees. Then we are going to cancel out the degree symbol. Then the 240 must be multiplied to the pi radian in the numerator and divided by 180. So that is why we have 240 pi over 180 radian. Then as we are going to simplify now 240 over 180, that is equal to 4/3. Then we can say the radian measure of 240 degrees is equal to 4 pi over 3 radian. Then step 2 is, using the radius, r is equal to 3 inches and the theta is equal to 4 pi over 3. Note that pi is equal to 3.1416 if we're talking about now length of a circle. You can now find the arc length by substituting the r, which is equal to 3 inches, and the theta, which is equal to 4 pi over 3. So that is why we have 3 inches times 4 pi over 3. Then we are going to cancel out the 3 because it is divisible by 3. Then we can say this is now 4 pi inches. If we are going to simplify further now the 4 pi inches, then we are going to substitute now the value of the pi, which is 3.1416. So we have now 4 times 3.1416 inches is equal to 12.57 inches. Then we can say that the arc length is equal to 12.57 inches. Example number 2. Find the length of an arc that subtends a central angle 120 degrees of a circle with a radius of 10 cm. Step 1. Use the formula S is equal to R times the theta. First, convert 120 degrees to radian measure. So we have 120 degrees multiply now to pi radian over 180 degrees. Then we are going to cancel out now the degree symbol. So we have 120 will be multiplied to the numerator pi radian. So that is why we have 120 pi over 180 radian. So as we are going to simplify now 120 over 180, their GCF is equal to 60. So that is why 120 divided by 60 is equal to 2, and 180 divided by 60 is equal to 3. So that is why 120 degrees is equal to 2 pi over 3 radian. Step 2, using the radius, r is equal to 10 centimeter, and the theta, which is 2 pi over 3. Note that pi is equal to 3.1416. You can find the arc length to be, so s is equal to radius times the theta. So that is why we have now 10 centimeter times 2 pi over 3. So as we are going to multiply now 10 centimeter times 2 pi. So approximately by multiplying now the 20 by the value of the pi, which is 3.1416, then the arc length of a circle that subtends a central angle 120 degrees with a radius of 10 centimeter is equal to 20.94 centimeter. Example number 3. Find the radius of an arc that is 156 centimeter in length and subtends an angle of 150 degrees to the circle's center. Step 1. To use the formula s is equal to radius times the theta, first convert 150 degrees to radian measure. So that is why we have 150 degrees times pi radian over 180 degrees. Cancel out the degree symbol. Then we have 150 pi over 180 radian. As we are going to simplify 150 pi over 180 radian, that is equal to 5 pi over 6 radian. Why? Because the GCF between 150 and 180 is equal to 30. So as we are going to divide now 150 divided by 30, that is equal to 5. And 180 divided by 30, that is equal to 6. That is why we have 5 pi over 6 radian. Step 2. Using s is equal to 156 centimeter and the theta 5 pi over 6. Note that the pi has an approximate value of 3.1416. You can find the radius to be. So we are going to use the formula arc length is equal to radius times the theta. So all we need to do is the value of the s, which is 156, will be substituted to the equation here, and also the value of the pi, which is 5 pi over 6, will be substituted to the theta in the equation. So that is why, as we are going to substitute on the value of the s and the theta, so that is why we have 156 centimeter is equal to radius times 5 pi over 6. And take note that pi is equal to 3.1416. So all we need to do is we are going to multiply first 3.1416 to 5 and divide it by 6. So as we are going to update our equation, so that is equal to 156 centimeter is equal to radius times 2.618. Because if you're going to simplify now this one using your calculator, this will be the result. And take note that we are going to find the value of the r here. So to isolate now the r, we are going to divide both sides by 2.618 in order for us to isolate the r, because we need to find now the value of the r in the problem. So as we are going to cancel out now 2.618, then we already isolated now the r. Then we are going to divide now 156 centimeter by 2.618. Then we can say that the radius is 59.59 centimeter, as we are going to round it off into 2 decimal places.
And that ends our video discussion at this moment. Thank you for watching. But before you will end this video, please do assess your learnings by answering the self-test activity. Thank you.